Sharks have a scary reputation in part thanks to Steven Spielberg's Jaws 1975, which hit screens 50 years ago and has been inspiring a fear of sharks in people ever since. But while they may look threatening with their mouths full of hundreds of razor-sharp teeth, sharks don't actually attack humans all that often. Shark defenders are commonly correcting that misconception, but there are plenty of other shark facts that aren't nearly as well known. Here are 10 wild things that you might not know about the fearsome fish. 10. Almost all Greenland sharks go blind. Greenland sharks, which swim the freezing waters of the North Atlantic and Arctic Oceans, have a reputation for being a bit slow and clumsy in comparison to other shark species. But in fairness to them, almost all of them go completely blind during adulthood. While Greenland sharks are born with fully functioning eyes, parasitic crustaceans called Omatocoida elongata often quickly embed themselves in the shark's eyes. Typically, each eye is home to an adult female and several larvae, which eat away at the shark's cornea over time. Most Greenland sharks are left only with enough vision to make out light and darkness. Although not being able to see isn't exactly ideal, they have an excellent sense of smell with which to track down their prey. Number 9. Swell sharks can double their size. Swell sharks aren't particularly aggressive or large, usually measuring a little less than 3 feet, 0.9 meters, from nose to tail as sharks go. So instead of lashing out at predators, including larger sharks and seals, they employ a unique defensive strategy, which is their namesake, swelling. Swell sharks will swim into a rocky crevice and then swallow large amounts of water to double their size. This allows them to get lodged between the rocks, making it harder for a predator to prize them free and take a bite. Once safe, the shark expels the water in their stomach with a dog-like bark. Swell sharks can also perform this expanding trick with air if they're brought to the surface, but it works less well for evading humans who have plucked them from the water. 8. Great whites might have helped drive the megalodon to extinction. The megalodon went extinct around 2.6 million years ago and is the largest shark ever known to have swum the oceans. While the great white is roughly 20 feet 6 meters in length and weighs under 4,400 pounds, 2 metric tons, the megalodon is thought to have stretched to almost 60 feet 18 meters and weighed 110,000 pounds 50 metric tons. But despite being so much bigger, it's thought that the Meg went extinct thanks, in part, to the great white. In 2022, a scientific paper was published that looked at the zinc isotopes in the teeth of both megalodon and great whites. While additional research is needed, our results appear to support the possibility for dietary competition of megalodon with early Pliocene great white sharks, explained Professor Kenshu Shimada. Both sharks are thought to have competed for the same prey, and the Meg's massive size worked against it in this regard because it needed more food to sustain itself. Along with being outcompeted for prey, cooling oceans also led to a more restricted habitat for the Meg. Both of these factors are likely what sent the huge shark to its watery grave. 7. Some sharks lay spiral-shaped eggs. Most sharks give birth to live pups, some of which, incidentally, cannibalize each other in the womb, but some species lay eggs instead. While bird eggs tend to be oval-shaped, shark eggs come in a variety of odd but practical shapes. The Port Jackson shark lays spiral-shaped eggs, for instance. Mark McGrowther, collection manager of ichthyology at the Australian Museum, explains that this is so that the mother shark can pick it up in her mouth and screw it into rocks and crevices to anchor it so that they don't wash away. The crested horn shark lays a similarly spiral-shaped egg, but with the addition of tightly spiraling tendrils attached to the bottom. The tendrils provide another opportunity for the egg to anchor itself by getting caught up in seaweed or algae. Other alien-esque shark eggs include those of the draftboard shark and the Australian ghost shark. The draftboard's eggs are a bright orange-yellow color and also feature spiral tendrils. In contrast, the ribbed edges of the ghost shark's eggs make them look like a stage of the xenomorph's life cycle. 6. Cookie-cutter sharks have taken bites out of submarines. In the 1,970 seconds, the U.S. Navy noticed strange circular holes in the rubber covers of the sonar domes on their submarines. They initially attributed the damage to a new enemy weapon, but after investigating, they found out that the holes were created by a previously misunderstood type of shark. The cookie-cutter shark is named for its distinctive bite mark, although the spherical shape actually more accurately resembles an ice cream scoop or a melon baller than a cookie-cutter. Although cookie-cutter sharks are fairly small, the biggest ones reach just under 2 feet, 56 centimeters. They have the largest teeth-to-body ratio of all shark species. They use their lips to suction onto their chosen prey, whether it be a submarine, whale, dolphin, or, in rare cases, a human. Once locked in place, they twist their body around to shear off a chunk of flesh with their teeth, leaving a distinctive hole behind. 3. Sharks don't have any bones. Most people have seen a shark skeleton in a film, book, or museum, but what you're looking at isn't actually a bone structure. It's cartilage. There isn't a single bone in the body of any shark species. Well, aside from any bones that they've eaten, with their frames instead being comprised of the same material that forms human ears and noses. The only hard part of their skeleton is their teeth, which are comprised of enameloid and dentine. Being light and more flexible than bone, cartilage means sharks can typically swim faster than bony fish, explains Emma Bernard, curator of fossil fish at the Natural History Museum in London. As well as enabling sharks to swim faster, it also makes their bite more powerful because they're able to open their mouths wider, thanks to the upper jaw not being fused to the skull. The areas of their skeleton that need a bit more support, the jaws, spine, and skull, are strengthened thanks to calcium salts, which come from their diet. 4. Some sharks can turn their stomachs inside out. Some shark species have a reputation for being garbage bins of the sea. Tiger sharks in particular will make a meal of anything, including rubber tires and metal license plates. While sharks have highly acidic stomachs that can break down many substances, they aren't able to digest absolutely everything. Some species have an odd way of dealing with this, by literally vomiting their stomachs. Known as stomach or gastric eversion, this process sees a shark expel its stomach out of its mouth to rinse it out in the water and then suck it back in. There are several reasons that sharks throw up, beyond getting rid of objects that can't pass into their intestines. In many cases, it's thought to be a stress response, possibly because it's easier to escape a stressful situation on an empty stomach. Sharks have also been observed throwing food up before returning for more likely because they've deemed a particular bite of meat to be substandard and want to make room for tastier morsels. 3. Shark skin is made up of tiny teeth. If you thought a shark's mouth was full of teeth, just wait until you learn about their skin. On a microscopic level, a shark's skin looks like it's covered in tiny razor-sharp teeth, and that's because it basically is. These toothy scales are called dermal denticles and are comprised of dentine, the same material that coats their teeth. If you stroke a shark one way, it'll feel smooth, but the other way it'll feel like sandpaper because of the jagged points of their dermal denticles. The shape and size of the denticles vary from species to species, but for all sharks, they serve the same two very practical functions. Firstly, the scales streamline the shark's body, which means that it can swim faster. Secondly, they provide a layer of protection, not only from other sharks taking a bite, this can happen accidentally while feeding or can be a deliberate attack, but also from smaller creatures that might want to latch on, such as parasites and barnacles. 2. Sharks existed before trees. You may have heard the fact that sharks outdate dinosaurs. They're often called living fossils, having managed to survive multiple extinction events, but did you know that they also outdate trees? In 2019, the oldest known fossilized trees were discovered in a quarry in New York, dating back 386 million years. But the oldest evidence of sharks, or rather the ancestors of sharks, has been dated to 450 million years ago. Shark-like scales from the late Ordovician have been found, but no teeth. If these were from sharks, it would suggest that the earliest forms could have been toothless. Scientists are still debating if these were true sharks or shark-like animals, explains Emma Bernard, the Natural History Museum's fossil fish curator. The earliest shark-like teeth to have been found belonging to a fish called Doliotis problematicus date back 410 million years, which remain significantly older than the oldest known trees. 1. Epaulette sharks can walk on land. Although the idea of a shark that can walk on land may sound scary, the epaulette shark is relatively small, around 3 feet, or 0.9 meters in length, and doesn't look all that threatening. Epaulette sharks live in the waters around Australia and Papua New Guinea, and their ability to walk on land is a skill that no other shark has mastered. When an epaulette finds itself beached, it slows its heart rate and breath to conserve oxygen. Then it uses its pelvic and pectoral fins as proto-legs to propel itself forward. Although the shark doesn't move very fast, it's able to shuffle itself back into the water. Other sharks are thankfully unlikely to develop this trait anytime soon. Epaulettes often forage for food in coral reefs and tide pools, habitats that can be covered by water during high tide but left open to the air during low tide. It's only because epaulettes find themselves beached so often that they have evolved to walk on land.